Transforming quadratic functions. When transforming quadratic functions, we're going to look at how narrow or wide a parabola is. So looking at this chart here, it says the value of a quadratic function determines not only the direction a parabola opens, but also the width of the parabola. So when we're looking at the width of a parabola, it says the graph of f of x equals ax squared is going to be narrower than a graph of f of x equals x squared if the absolute value of a is greater than 1, and wider if the absolute value of a is less than 1. So if a is greater than 1, your parabola is going to be wider than it would be if the absolute value of a is less than 1. So what they're doing here is they're looking at different graphs, and they want you to compare the graphs of g of x and h of x with the graph of f of x. So f of x is x squared, it's the red graph. Notice h of x, you have 1/4 x squared. Notice that's the blue graph, and the parabola is much wider than the red graph of x squared. Then we have g of x, which is negative 2x squared. So negative, it's opening downward for the negative a, and then notice the width compared to x squared and 1/4 x squared. So we're going to be looking at how parabolas are graphed, and looking at the actual parabola, how narrow or wide the parabola itself is. Here we're going to be comparing the coefficients with following functions. So here we have f of x equals x squared, g of x equals x squared minus 4, and h of x equals x squared plus 3. The only difference with these three quadratic functions is the last value is changing. So your a's are all the same, your b's are all the same, but what's different is your value c. And what you're doing here is when you graph these different functions, notice when you have f of x equals x squared, that's the red graph. When you have g of x, x squared minus 4, here it is as the green graph. And then we have h of x equals x squared plus 3, that's the blue graph. Notice they're all the same width, but where they fall on the y-axis is different, and that makes sense because with the red graph there's no c value, so that'd be at 0. The c value for h is 3, so at y we go up to 3 and we make our parabola. And our g of x, our c value is negative 4. So what's the same? All of our axis of symmetries are going to be the same, which x equals 0. And the width of the parabolas are going to be the same, but what's different is the vertex of the parabola. When we're looking at vertical translations of a parabola, that's when the graph of the function f of x equals x squared plus c is the graph of f of x equals x squared, translated vertically. If c is greater than 0, then the graph of f of x equals x squared is translated c units up. So when c is greater than 0, it translates up. When c is less than 0, your graph, your parabola, is going to translate down, moving up or down along the y-axis like we saw in the previous example. Let's look at some equations here, or some situations, and for the first example here we're going to determine, put these functions in order based on narrowest graph to widest graph. So we're going to look here, f of x equals negative x squared, g of x equals 2/3 x squared. So notice the first graph has a negative value, negative a. The second one has a fraction 2/3. So based on how narrow or wide the graph is, it's going to go in a specific order, but we need to first look at a. So our a value is going to be negative 1 and 2/3. When your a is greater than 1, it's going to be wider. If your a is less than 1, it's going to be more narrow. So my f of x is going to be more narrow than my g of x. So my -1 is going to be more narrow than my 2/3. Looking at b here, we have f of x equals -4x squared, g of x is 6x squared, h of x is 0.2x squared. So we have to look at all of my a values. So which one is going to be the narrowest? That's going to be my whole value here, my g of x was 6x squared. Then it's going to be my f of x, my -4x squared. My widest graph is going to be h of x, which is 0.2x squared. So here's my answer. The order from narrowest to widest is g of x, f of x, then h of x. Now we're going to compare the graphs of the function. We're going to compare it based on f of x equals x squared. So we have here g of x is -x squared minus 4. So here's the different graphs. My red graph is representing x squared. My blue graph is representing that -x squared minus 4. So to compare these two graphs, what we can say is my g of x opens downward. My f of x is going to open upward. What's the same with these graphs? They have the same axis of symmetry. So we're comparing what's different and what's the same. So they both have the same axis of symmetry. The vertex is going to be different. For f of x, x squared is 0, 0. For the vertex of g of x, the vertex of g of x is going to be 0, -4. Because notice my y value is at -4 right there. So that's the difference of the two. Looking at g of x, 3x squared plus 9. Here's my different graphs. So notice my 3x squared plus 9 is much narrower than my x squared. So what can we compare about this? Since 3 is greater than 1, the graph g of x is going to be narrower than f of x. Both of the functions have the same axis of symmetry, which is 0. X is 0. What's different with these is the vertex. The vertex of f of x is 0, 0. The vertex of 3x squared plus 9 is going to be 0, 9. Something that these graphs have in common is that they both open upwards. Our last graph here, we have g of x equals ½ x squared plus 2. When I graph them, notice that my red is my x squared, my blue is my ½ x squared plus 2. Notice my x squared is more narrow than my ½ x squared. Fractions, when you have a fraction for your a value, fractions are going to be much wider than you would have, than it would be for a whole number value, like 3 or 1 or whatnot. How can we compare these two graphs? Well, g of x is wider than f of x, and the graph of g of x opens upward. The graph of f of x opens upward as well. So they're both opening upward, but one is more narrow than the other. So that's how we compare and contrast these. So looking at the value that's in front of a, that represents a, that's going to determine how narrow or wide your parabola is. When it's a whole number, it's going to be more narrow. When it's a decimal or a fraction, it's going to be wider. And then you also have to make note if you have a negative in front of, for your a negative value for your a.